Okay, well, we're back. So a triangle with achieving coming down to the opposite side does not need to be the angle bisector, it could be anything. This very straightforward formula involving only the side lengths helps you find one of them if you're missing one of them. And in our prior example, we knew we had a 3, 4, 5 triangle and the angle bisector, and this side was 15/7 and this side was 20/7. So we knew A, B, C, M, and N, so we can easily find p squared. And it just comes from the law of cosines. So we have from the law of cosines, if I call this theta and this 180 minus theta.
All right.
Sorry, I'm having to write so small. What does the law of cosines say about B?
So it says that b squared equals p squared plus m squared minus 2 times p times m times cosine theta.
Now what about c squared? What does c squared equal?
So it's p squared plus n squared minus 2pn cosine 180 minus theta.
So I'm going to call that theta prime just because I'm out of room.
Right.
And I was going to make parentheses, but I'll just make this. Okay, now what's the relationship between cosine theta and cosine 180 minus theta?
Well, they add up to cosine 180. They add up to minus 1.
What do you mean?
Like, cosine theta and cosine 180 minus theta add up to cosine of 180.
What?
No, wait. That's not true.
It's definitely not true.
Cosine 180 minus theta is negative cosine theta.
Okay, so there you go. So when I have our unit circle, I have cosine theta here. Cosine 180 minus theta would be this angle with this theta missing here.
Mm-hmm.
So that this angle plus this angle add up. The angles add up to 180.
Yeah.
But the cosines are the x coordinates, which are just opposite of each other. They're negatives of each other.
Yeah.
So this becomes plus 2pn cosine theta.
Alright.
You see that? Now it'd be great to get rid of this cosine theta part, but unfortunately we don't have the same thing here.
Yeah.
So do you see what we can do to make these two expressions here become the same thing?
Well, I can see we can make them have the same variables in them.
Okay.
We can say that n is a minus m.
Yeah, I'm going to do something even simpler than that. I'm going to multiply this equation by n and multiply this equation by m. So I get n minus 2pn cosine theta, and then I go m minus 2pmn cosine theta. So what happens when I add these equations together now?
So this goes away.
This goes away. The complicated part with the cosine theta goes away. And I get this very interesting expression on this side, which is b squared n plus c squared m, which is what we have up here, equals p squared times what?
Mn, or m plus n.
M plus n. And this expression here, I can take out an nm from, and what do I get inside of that?
M plus n.
M plus n.
Which is a.
Which is a.
You can take the a out of everything.
Yeah, I'm going to factor out an n plus n, and I get a times p squared plus n. So it's actually not that difficult to derive. If you remember that cosine of theta and cosine 180 minus theta are
negatives
of each other. Okay, so let's go back and solve your problem using Stewart's formula.
Alright.